You've been watching Homeschool 101, a partnership between ABS Television and the Ministry of Education. Thank you for viewing this lesson. Join us again next time.
Welcome everyone to the final class in Homeschool 101. For today's integrated mathematics class, we're looking at the third module, calculus, and we're looking at the topic, limits and continuity. At the end of today's class, you should be able to describe the limiting behavior of a function of x as x approaches a given number. You should be able to use the limit notation, evaluate limits using simple limit theorems, apply factorization to expressions whose limits are indeterminate, evaluate limits to infinity, apply the concept of left-hand and right-hand limits to continuity, and finally identify the points for which a function is discontinuous. Now, when we think about limits, what are some real-life applications of limits? Limits are used to define continuity, derivatives, and integrals. Specifically in chemistry, when we're dealing with a chemical reaction in which two chemicals are reacting to produce a new compound, the amount of new compound is the limit of a function as time approaches infinity. When we think about business, limits are used in business to assess changes in variables. It is used to determine the opportune time to buy or sell goods, pricing, etc. Finally, in medicine, it is used in studying how medicines act in the body. For example, it's used to determine the concentration of the medicine in the body after a given time. So the definition of a limit. So the limit of f of x as x approaches a is the number L written. The limit of f of x as x approaches a equals L, provided that f of x is arbitrarily close to L for all x sufficiently close to but not equal to a. Essentially, when we define the limit of a function, we're looking at how the function changes as we approach a particular value. Not necessarily what happens at the value, but how the function changes as we approach that value of a. In terms of limit theorems, there are 5 theorems that we will go through. And it says if the limit of f of x as x tends to a is equal to f, and the limit of g of x as x tends to a is equal to g, and k is a constant, then the theorems are, first one, the limit of a constant is itself. Once we're evaluating the limit of a constant, it is always itself. The second one, once we have the limit of a function x to a power, what we simply need to do is to substitute a for x into the function and evaluate. The third theorem states that once we're finding the limit of 2 terms, we can evaluate the theorem, each term individually, and then take the sum. The fourth limit states that once we're finding the limit of an expression or a variable that is being multiplied by a constant, we can simply evaluate the function and then multiply by that constant. And the final theorem states that once we have a limit of a fraction, we can evaluate the limit of the numerator and the denominator and then combine. When evaluating limits, there are basically 2 methods that we will look at. We will look at a direct substitution, and the second method would be factorization and cancellation, followed by a direct substitution.
You're watching Homeschool 101.
Alright, so we will look at evaluating limits by direct substitution. So I have 2 examples here and we will go through. So for the first example, it states evaluate the limit of x squared plus x minus 4 as x tends to 3. So because we're using the method of direct substitution, what it means is that we will substitute x for 3 into the function. So it becomes 3 squared plus 3 minus 4, and that gives me a value of 8. For my second example, I'm evaluating the limit of 4x squared minus 9 divided by 2x minus 3 as x tends to 0. So again, what we will do is to substitute the value of x, in this case it is 0, into the function for x. So it becomes 4 times 0 squared minus 9 divided by 2 times 0 minus 3. So we know that 0 times anything would give us 0, hence this portion would become 0, and what we're left with is negative 9 divided by negative 3. Again, once we're dividing and we have two negative signs, the signs would cancel, and what I'm left with is positive 3. So in the method of direct substitution, I directly substitute the value of x into the function. So we will look at indeterminate forms of limits. So an indeterminate form of a limit is a form in which we do not have enough information to evaluate the limits. We end up with a case where we have 0 divided by 0, and that is considered an indeterminate form since it can be 1, infinity, or 0. And remember, we know that if you try to divide anything by 0 in your calculator, you will end up with an error because we can't divide by 0. So what we would need to do is to find another way in order to evaluate this limit. And this brings us to our second method, which is to evaluate by factorization and cancellation, which would then be followed by direct substitution. So if we look at this example here, so it states evaluate x minus 3, the limit of x minus 3 divided by x squared minus 9 as x tends to 3. So what we would do is to first try by using a direct substitution. So if I substitute x for 3 into this function, I would end up with a value of 0 divided by 0. And this is what we consider an indeterminate form. Hence, we cannot directly substitute, but what we would need to do is to factor the expression. Now, if we look carefully at the limit that we have, if we look at the denominator, x squared minus 9, we can see that x squared minus 9 is a difference of squares. So we can rewrite x squared minus 9 as x minus 3 times x plus 3. Once we have factorized, we can go ahead and cancel. In this case, I would cancel x minus 3 and x minus 3. I'm left with a fraction 1 divided by x plus 3. And the key thing to note, please pay close attention to this, because I know sometimes persons would cancel and they forget that a 1 is in the numerator. So once we cancel, it becomes a fraction 1 divided by x plus 3. Now that we have simplified, we can then go ahead and do our direct substitution. So if I substitute x for 3 into this function, it becomes 1 divided by 3 plus 3, which gives me 1 divided by 6. So in cases where we attempt to do a direct substitution and we end up with 0 divided by 0, we know that this is an indeterminate form. Hence, we need to use the second method, which is the method of factorization and cancellation. We factor the terms, cancel, and then we do a direct substitution. So I have an activity here for you to attempt. So it states evaluate the following, the limit of x squared minus 4 divided by x minus 2 as x tends to 2. So go through, evaluate this question, and determine which of these is the correct answer. So we will take a break while you make an attempt at the question.
You're watching Homeschool 101.
Alright, so welcome back. We will go through the activity. So it states evaluate the following. So what we would need to do is to, as you would see, if you attempted a direct substitution, you would end up with a value of 0 over 0. Hence, you would need to factorize and then cancel. So if we're looking at the numerator, x squared minus 4, x squared minus 4, that is also a difference of squares. So it is x minus 2 times x plus 2. We cancel, then we do our direct substitution, and we end up with a value of 4. Hence, the correct answer is C from the options that were given. So we can also evaluate limits to infinity. And there are 3 types, there are 3 possible outcomes when we're looking at limits to infinity. When the degree of the polynomial is the same in both the numerator and denominator, the function approaches a constant. And the degree of the polynomial speaks to the highest power to which the variable is raised. So once the power in the numerator and the denominator is the same, once they are both the same, then we would end up with a constant when we approach that limit. The second option, when the degree of the polynomial in the numerator is greater than that in the denominator, the function approaches infinity. And finally, when the degree of the polynomial in the denominator is larger or greater than that in the numerator, the function approaches 0. Now we will look at some examples. So for the first example, we're looking at the case when the degree of the polynomial in both the numerator and the denominator are the same. So it states, evaluate the limit of 3x squared minus x divided by 2x squared minus 1 as x tends to infinity. Now we mentioned that the degree of the polynomial is the highest power to which the variable is raised. So looking at our function, the degree of the polynomial here is 2. As we can see in the numerator and denominator, the highest power of x is 2. So what we would simply do is to factor out the highest power of x from both the numerator and denominator. So when we take out x squared as a common factor in my numerator, I'm left with 3 minus 1 divided by x. In the denominator, I'm left with 2 minus 1 divided by x squared. What I would then do is to cancel the x squares, and I'm left with 3 minus 1 over x divided by 2 minus 1 over x squared. We will then proceed to directly substitute. And the key thing to note when we're evaluating limits to infinity, we would try to simplify as much as possible and then we substitute. So in this case, if I substitute, 1 becomes 3 minus 1 divided by infinity divided by 2 minus 1 divided by infinity squared. Now if we're looking at 1 divided by infinity, we know that a constant divided by a very large number, and we know infinity is very large, extremely large. And once we divide 1 by infinity, that value will approach 0. So once we have a case where we have a constant being divided by infinity, that automatically, or that becomes 0. So 1 divided by infinity and 1 divided by infinity squared, that would become 0. So all we're left with would be the constant 3 divided by 2, and that would give us our solution. So essentially, when the degree of the polynomial is the same, we end up with a constant. Now there are two methods. What we can simply do is to focus on the terms with the highest power of x. So in this case, instead of looking at the x and the 1, I could just focus on my terms that contains the highest power of x. So in this case, in the second method, I could simply rewrite this as 3x squared divided by 2x squared. I would then go ahead and do my substitution, 3 infinity squared divided by 2 infinity squared. I would then cancel my infinity squares, and I'm left with the constant 3 divided by 2. So essentially, when we're evaluating the limit to infinity, or we can select any of these two methods. We can simply, for time, because I know usually when in exams you have limited amount of time, so what you would need to do is to select the simpler method, or the one that can be done in the quickest possible time. So in this case, you could just use method 2, which is to just look at the terms containing the highest power of x and simplify. The second example, when the degree of the polynomial in the numerator is greater than that in the denominator. So again, we have another question here. So it's a limit of 5x cubed minus 20 divided by 4x squared minus x as x tends to infinity. So again, using both methods. For the first method, we take the highest common factor. So we factor x squared from both the numerator and the denominator. When x squared is taken out, we're left with 5x minus 20 divided by x squared divided by 4 minus 1 divided by x. I can then go ahead and do my substitution here, where I substitute x for infinity. Now this case, once I have a constant being divided by infinity or infinity squared, that is going to become 0. And the same thing in the denominator here. So I'm left with 5 infinity divided by 4. Now we know that infinity is an extremely large number, and if we multiply that by 5, it is an even bigger number. So if we divide that by 4, it is still essentially infinity. So when the degree of the polynomial in the numerator is greater than that in the denominator, it approaches infinity. So looking at the second solution again, if we're only focusing on the terms with the highest power of x in both the numerator and denominator, it becomes a limit of 5x cubed divided by 4x squared as x tends to infinity. I can then simplify using my knowledge of exponents. So I would simply subtract the power of x in the denominator. So remember from exponents, a to the n divided by a to the m is equal to a to the n minus m. So x cubed minus 2 would give me x. So I'm left with 5x divided by 4. I can then go ahead and do my direct substitution. So it becomes 5 infinity divided by 4, which gives me infinity. And the final example, when the degree of the polynomial in the denominator is greater than that in the numerator. So it states, evaluate the limit of x minus 5 divided by x squared minus 4 as x tends to infinity. So again, what we would need to do is to take the highest common factor of the variable. So we factor x from both the numerator and the denominator. Once that is done, we cancel the x's and we're left with 1 minus 5 divided by x in the numerator and x minus 4 divided by x. We can then directly substitute. This becomes 1 minus 5 divided by infinity divided by infinity minus 4 divided by infinity. Again, the constant divided by infinity, that tends to 0. So what I'm left with is 1 divided by infinity. And again, once I'm dividing a constant by an extremely large number, it becomes 0. If we're using the second method, again, I would just focus on the terms, the terms containing the highest power of x in both the numerator and the denominator. In this case, it would be x divided by x squared. Again, I simplify using the laws of exponents or the properties of exponents. So I'm left with 1 divided by x. I then do my direct substitution, so it becomes 1 divided by infinity, which gives me 0. So the third case, once the degree of the polynomial in the denominator is greater than that in the numerator, the function approaches 0. So I have the second activity for you to attempt applying your knowledge of what we just went through. We have the limit of 3x divided by x squared as x tends to infinity, and you will complete this question.
You're watching Homeschool 101.
So just go through, think about whether the degree in the polynomial in the numerator is greater than that in the denominator. Try to remember what the options are and then evaluate this limit. We will now go through the solution. So for this question, the correct answer was A. So given the limit of 3x divided by x squared, in this case, we know that the degree of the polynomial in the denominator is greater than that in the numerator, hence the function would approach a value of 0. So to go through, we would simplify using exponents. We then do our direct substitution, so it becomes 3 divided by infinity, which gives me a value of 0. We will then proceed to look at one-sided limits. With one-sided limits, we are looking only at one side of the point in question. For left-hand limits, we have the limit of f of x as x is equal to L as x approaches a to the minus. We would see signs here. To determine or to know whether it's a one-sided limit, you would usually see the signs, either a negative sign here or a positive sign. Now, the sign does not mean that the values are negative. What it means, if I have a negative sign, it means I'm looking at how the function changes as approach from a value that is less than a. And the positive sign would mean I'm looking at how the function changes as I approach from a value that is greater than a. And when we're evaluating limits, the limit exists if and only if both one-sided limits exist and are equal. So we have an example here. So it states a function f is defined by, and we have f of x is equal to, and this is considered a piecewise function where we have different equations depending on what the value of x is. So in this case, the function, it is x squared minus 12 if x is less than negative 2, and 2x plus 5 if x is greater than or equal to negative 2. So it states evaluate the following. So we're evaluating one-sided limits. So it states evaluate the limit of f of x as x approaches negative 2, and we have the negative sign here, meaning we're looking at it from the left-hand side. And the second question, the limit of f of x as x approaches negative 2, with from the right-hand side indicated by the plus sign. And finally, we need to determine if the limit exists. So to go through, in evaluating the first part, the limit as x approaches from the left-hand side, what we would need to do is to use the equation that deals with values of x that are less than negative 2. And that would mean we're looking at the first equation. So what I would simply do is to substitute x for negative 2 into this equation and simplify. So it becomes negative 2 squared minus 12. Again, once we take the square root, the square of a negative number, it becomes positive. Hence, it is 4 minus 12, which gives me a value of negative 8. For the second question, I would look at how the function changes as it approaches from a value that is greater than negative 2, and hence I would substitute into the second equation. So substituting, it becomes 2 times negative 2 plus 5. That gives me a value of 1. So please note, remember the signs, a positive times a negative gives me a negative, and once I'm taking the sum of two values and their signs are different, I subtract the smaller from the larger and rewrite the sign of the larger. To answer the final question, it states, does the limit of f of x as x approaches negative 2 exist? Now remember we said that the limit exists if both the left hand and the right hand limits exist and are equal. In this case, because I have a negative 8 and a 1, the values are not the same, hence the limit does not exist because left hand and right hand limits are not equal. Okay, so we will look at our third activity. It states a piecewise function f of x is defined as, and we have the function here, evaluate the limit of f of x as x approaches negative 3, and with a plus sign, so we see the plus sign, meaning we are evaluating one-side limits. So go ahead, make an attempt at this question, and then we will go through.
You're watching Homeschool 101.
Okay, so let us go through the solution. So, because it states x approaches negative 3 and there is a plus sign there, it means we're looking at how the function changes when we approach from a value that is greater than negative 3. So for that, it means we will have to use our first equation, because the first equation looks at values of x that are greater than negative 3. So what we would do is to substitute negative 3 into the first equation for x. So it becomes 3 times negative 3 minus 4, and that gives me a value of negative 13, hence the correct answer, A. The final section we will look at for limits and continuity is continuity. And the definition of function f is continuous at A if and only if the following three conditions are met. So the first condition is that f of x is defined at x is equal to A. The second condition is that the limit must exist. And remember, if we're evaluating one-sided limits, the limit exists if and only if both one-sided limits are equal. And the third condition is that the limit of the function must be equal to f of A. So So the function is not continuous, or we would say discontinuous, if these three conditions are not satisfied. So an example, the function f is defined, and we have the function here, f of x is equal to 4x minus 2 for x greater than 3, and x squared plus 1 for x less than or equal to 3. We need to determine if the function is continuous at x is equal to 3. Now again, remember, for the function to be continuous, it must satisfy the following three conditions. It must be defined, and for it to be defined, we must see in the question an expression stating x is equal to 3, and we will substitute the value of x in that function. So in the second function, we see we would use that when x is less than or equal to 3. So to determine if f of x is defined, we substitute x in that equation. So f of 3 becomes 3 squared plus 1, which gives me a value of 9 plus 1, which is equal to 10. The second condition is that the limit must exist. And because I have two separate functions, two separate equations that deal with the values of x, I must evaluate both left-hand and right-hand side limits. So I substitute x for 3 into the first equation. That gives me a value of 4x minus 2, which gives me 10. And if it is substituted in the second equation, that also gives me a value of 10. So as you can see, both left-hand and right-hand side limits are equal, hence the limit exists. And the final condition is that the limit of f of x must be equal to f of a. As we can see, we end up with 10 in both cases, and because all three conditions are satisfied, it therefore means that the function is continuous at x is equal to 3. Another example, it states find the points of discontinuity if they exist of the following. So we're given g of x is equal to 8x divided by x squared minus 36. So we know that in order to find the points of discontinuity, what we would need to do is to find what values of x, when substituted, would result in 0 with 0 in the denominator. Because we know we can't divide by 0, it would be undefined. So if an x value, when substituted in the denominator, gives us a value of 0, we know that the function would be discontinuous at those points. So in order to evaluate this, what we would need to do is to equate the denominator to 0 and solve. So it becomes x squared minus 3x is equal to 0. I take across x squared minus 36 is equal to 0. I take across the 36, it becomes positive because once the value goes across the equal sign, the sign changes. I then take the square root, and remember that once you take the square root, it gives you two values, one that is positive and one that is negative. So both x values would be positive 6 and negative 6. Hence, the function is discontinuous when x is equal to negative 6 or positive 6. When I substitute any of these values into the denominator, that would give me 0. A key thing to note, once we're dealing with points of discontinuity, once we have a linear function, it will always be continuous. Because once we substitute a value, we will always get an output. Once we have a fraction, then we would need to evaluate and to find the points of discontinuity. And the final example for you to attempt, it states identify the point or points of discontinuity if they exist of the following. So we're given f of x is equal to 13x divided by x plus 2 times x minus 5. And the options are here, A, B, C, and D. Determine which of these is the correct option.
You're watching Homeschool 101.
So let us go through the solution. So again, in order to obtain the points of discontinuity, what we would need to do is to equate the denominator to 0. So equating it becomes x plus 2 times x minus 5 is equal to 0. We then equate them individually to 0, and it becomes, in this case, I have x plus 2 Once the 2 goes across the equal sign, it becomes negative, hence it is x minus 2. And in this case, I have x minus 5. Once the negative 5 goes across the equal sign, it becomes positive 5. Hence, the correct answer, C, with the options x is equal to negative 2 and x is equal to 5. So this brings us to the end of today's class. And we would have looked at the limiting behavior of a function of x as x approaches a given number. We looked at limit notations, limit theorems, different methods of evaluating limits. We looked at the indeterminate forms of limits and evaluated limits to infinity. We evaluated left-hand and right-hand limits. We looked at on continuity, and finally we identify the points for which a function is discontinuous. Now this brings us to the end of today's class and the end of the lessons on Homeschool 101 for integrated mathematics. I do hope you found the sessions, they were very helpful, and I wish you all the best in your exams. And what I would encourage you to do as you prepare, practice, practice, practice. That is the key. Practice. Go through the various worksheets that you have, go back through the various examples, and just do your best. And once you do your best, that is enough. All the best. Take care.
You've been watching Homeschool 101, a partnership between ABS Television and the Ministry of Education. Thank you for viewing this lesson. Join us again next time.